Okay. Yes. Hello, friends. Welcome to BISP Solutions. BISP Solutions is a tech company and provide technological solutions across the world. And myself, Ashwin. And so today we are going to see. Just hold on. Just hold on. Just a second. Okay. Now, yes. Okay. So now, in this video, in this bootcamp session, we are going to see that how a vendor evaluation scorecard is created, right? Now, see, I have downloaded some vendor related data. Let me show you some example here. Here it is. Let me show you here. Okay, so I have downloaded some vendor related data from NetSuite. Right now, let it open. Here. Now see here. Here, quality score, cost efficiency, delivery time, compliance, responsiveness, and total score. Now see exactly what we are going to do today. Let me give you one scenario first. Scenario is, suppose if in a school, if a scorecard is to be created, right, a scorecard is to be generated of a student. So in that case, what will happen? The teachers, they will check how many times the student come on time, particular student or every student, right? Suppose there are 60 students in a class and the teacher is asked to prepare a scorecard of every student. Now in that case, what will happen? Teacher will check the past history of every student for the last 1 year. So the past 1 year, how many student, which student comes on what time, the teacher will take that under observation, under consideration. Then second thing, which student was neat and clean for the whole year. Then the third thing, which student completed his homework on given time. Fourth, which student behaved properly without any nuisance. Fifth, which student speaks politely with the elders or the teachers, right? So these are some criteria on the basis of which the scorecard of the every student is prepared, right? Now, now in that case, what will happen? Just a second. Yeah. Now in that case, what will happen? The scorecard is prepared. So the same scenario that we are taking in this example. Now see, we are preparing a vendors evaluation scorecard. Vendors evaluation. We are evaluating the vendors, that which vendor is the best. Now for this purpose, what we do, we take the quality score, what type of quality product that a vendor sells, cost efficiency, what type of cost efficiency, delivery timeliness, whether that vendor has delivered the product on time, compliances, right, whether the vendor follows all the compliances. Then responsiveness, how much time is the response time of that vendor. Suppose if I call a vendor to send like 4 steel bars, 4 ton steel bars. Now in that case, what will be the response time of that vendor, that we will send it tomorrow, day after tomorrow, what will be the response time? Then the third is, and finally the score, total score is generated, right? So similarly, we are doing the same thing here only, right, here also. So let me give you an example first. What is vendor scorecard? Now this vendor scorecard, first see this. A vendor scorecard is also a balanced scorecard or supplier's performance scorecard. Is a tool businesses use to evaluate and monitor the performance of their vendor for the whole year. What was the performance of that vendor, right? So vendor metrics, delivery performance, how is the delivery performance, If you see in you might have observed in your daily life also, like water supplier, water cane supplier. In many offices, the water cane suppliers, they supplies the drinking water. So in that case, what is the delivery performance? Many of the suppliers, they come immediately to supply the water cans, but a few suppliers, they just deny. So that is called performance score. Delivery performance. Product quality is also there. For example, if I supplies any water can to you, and now that water can, what type of water is that, whether it is too much dirty or a clean water, the cane is also clean or uncleaned, that depends on the product quality. Service efficiency, what type of person I send to you. Suppose that person is a rude person, he never listens to you, so that type of service efficiency. Compliances metrics, there are some set rules that every supplier, every vendor, every service provider has to follow. Like if you might have heard in real estate, there is a RERA compliance, right? RERA compliance. So there are some certain rules and regulations that everyone has to follow. Pricing performance means how the cost of that changes of that services, right, according to time. So all these things, they are counted, right? Just a second. Okay, yeah. Now, so this is what we are going to evaluate. Okay, so now let's see this. Let me show you some practical also. So here I have downloaded the data from the NetSuite, right? So I have downloaded this data from NetSuite. That is why this NetSuite icon is placed here. So our agenda is to study how this machine learning concepts help a business. That's it. Normally businessmen, in olden days when there were no machine learning, businessmen used to do lots and lots of homework, and that they used to apply or deploy some persons on this task, and they take 5 to 6 days, and after 5 to 6 days they give their report. So all these things can be done with the help of machine learning tools, and it's not very difficult. Just create your website, or if you don't want to create your website, you can directly use these machine learning tools on Jupyter Notebook, right? So that is the thing that we need to do. Now suppose here, let's go here in the practical scenario. I am going to create a new IPython file, that is interactive Python notebook. Okay, interactive Python notebook. Now see here. Now in this, what happened, I have downloaded, since I have told you that I have downloaded it from the NetSuite. Okay, so now in this NetSuite file, we need to first download some important files, important libraries. So these libraries will be used. These libraries will be used to evaluate. So Torch is a Torch library. NN means neural network. Optim means optimization. Train, test, split. As we know that training and testing data, we have to separate that data. Sklearn, standard scaler, it divides the data into -1 to 1. Then pandas is a well-known library which is used. Plotting library is used for plotting the diagram. NumPy is a NumPy library, right? Numerical values. It will convert the data into NumPy, and then again it will be reversed. Okay. So now what we are going to do, first of all, let's see this. Here I have written, I have taken first the data, vendor scorecard, right? .csv. This is the historical data, not the real data. This is historical data, that means not current data. Sorry, not the current data. It's a historical data. And in this historical data, what we need to do, based on historical data, it generates, it creates some pattern, and that pattern, on the basis of that pattern, it will create the data or the scorecard, right? So let's do this data, right? Now here is the data. Let me do it once more. Now here is the data. See here, vendor scorecard, vendor ID, quality score, cost efficiency, delivery timeliness, compliances, responsiveness, and the total score. Here the score is maximum, the score, that means the maximum the efficient that vendor is, and this is how the evaluation is done. If the score is low, that means vendor is not okay, and if the score is high, that means vendor is absolutely perfect. Okay, so we don't need this vendor ID first, right? We don't need this vendor ID, and we have to separate the data into two variables, as we know doing for the last so many sessions. Separate the data first. X, that is the independent variable, or we can say the features. So score, quality score, cost efficiency, delivery timeliness, compliances, responsiveness, these are the features, and total score, that is what we need to extract, right? So here what we have done, first of all, X data dot drop column vendor ID and total score, that means we don't need this, and y equal to data total score value reshape -1 to 1. Now if I put here X, so here you can see all the values 7.359734 they are same, but they are value separate, comma separated values. Okay, and after that, if you see the y value, just a second, y value, now you see the y value is also separated in the same format, right? So it is just, for example, if let me show you 7.359734 instead of that 34, it is written 3392, right? So after that we will use the train test split, right? Train test split here. Now just a second, here what we have done here, we have separated the data into two formats. One is the training data and another is the testing data. Training data is 80% and testing data is 20%. Suppose again the same thing, here there are thousands of rows, right? So 800 rows will be separated into training, remaining 200 will be in the testing. So this is the common thing that we have been doing. Then we have to do the standard scalar also. See, scalar X, scalar Y. Why we need to do this? Because suppose if I do scalar X, just a second, what we need to do here, first of all, scalar underscore X, this is the standard scalar, we have just added this, right? Now what we have done, scalar X dot fit transform X train, X test scalar dot X fit transform. Now see here what will happen, X underscore train. Now look at this, the data is converted into the standard scalar, look at this, right, into a format that the machine understand, right? Machine learning algorithm understands. After that, if you see convert to tensor, then we will convert it into tensor. Tensor means is just a matrix. So here float 32 is the by default data type, and if I type here X train tensor, look at this, the data is converted into their standard number, right? We have converted it to tensor, means the tensor is the language that the machine learning algorithm understands, DNN, right? Deep neural network, it will understand. So that is why we need to convert the complete data into this format, right? Then if you see here 6th point, that is now here what we have done, vendor score models, we have to create one algorithm, or we can say the function or the class. Here you will see init and then self.net sequential NN neural network dot sequential, it's a sequential data, NN dot linear input size, comma 64 is the number of neural network, right? 64 is the number of neural network. That means 64 neural networks will be created. then the ReLU function will be executed. ReLU function, it removes all the negative values, right? Then whatever the 64 is the input and 32 is the new neural networks. After that ReLU function, it is just like that. For example, just like that, take an example that 10 candidates are in front of me for the interview. So I will ask 20 questions to each candidate, and I filtered out only 5. Now these 5 candidates, I will ask only 5 questions related to each candidate. Finally, only one candidate I have to select, right? One candidate or 2. I will ask again 2 to 3 questions. That is the final round. It is just like that, right? First of all, 64 neural networks will be created. They are the layers, neural layers, on the basis of which the data is filtered out. Secondly, ReLU network, it converts the negative values, it removes the negative values. Okay. Third, linear, again 64 is the input and 32 is the new input. Again the ReLU function is executed, and then finally the one output will be generated. This is a function that we have created, and here forward self.x, here we are passing the data, right? We are passing the data from here. Now next step is, let's see this. Okay, here you will see model equal to vendor score model equal to input size x shape 1. Now input size x dot shape 1 means the variable, and out of which 5 columns, right? 5 columns we are inserting. Shape 1, see here, let me show you this. If I x1, wait a second, x dot shape 1. Okay, if I click here, x dot shape 1, x dot, look at this 5. This 5 means x dot shape 1 means this is the 5, right? Then criteria is NN dot MSE loss, mean square error loss. So difference between the actual scorecard and predicted scorecard, this MSE loss will evaluate that. It will calculate the loss between the actual and the predicted. After that, optim.adam and model.parameters learning rate. So whatever the loss will come, we have to reduce it. Okay, so we have to reduce it. So it will do the task of reducing the loss. Clear? It is completely technical. Now see here, as our usual work, we will do here the epochs. Now see, we are doing the training of the data. Now what we are doing, train losses, an array is created and it is empty right now. Epochs range is like 200. Each time is set to training mode. Now see, each time when this epochs is running, the model is set to training mode, right? Secondly, zero gradient. Optimization start with fresh 0. Okay, every time optimization will start with fresh 0. Then output model x. Now see, pass the value of x and predicted total score will be given in output and will be compared in loss variables. Whatever the we have passed this x train tensor, right? So here it is written pass the value of x and predicted total will be given in output, here output, and this output and this y train output, and will be compared with loss variable, and then compared with loss variable. This output and this y train tensor, they will be compared and that will be given in the loss variable. Okay, after that, if you see here, loss dot backward, if there is a loss, then again data will pass in model, that is called back propagation. That is why it is written here backward. If there is a loss, then again the data will be passed in model, right? Suppose there is a loss in the data, in that case it will again passed into the back propagation. After that, optimizer dot step. When we pass value, then with help of optimizer we pass some parameters so that we can optimize the output, right? So we have to optimize the output, right? So here, that is why we have done here. and after that we have given the this train losses. Now we are running this epochs. Now you can see here the loss 0.5905, it becomes less, that is 0.12, then 0.02. All in this way the loss is reduced. After that, what happens? Evaluation. Now evaluation means exactly what? Let me show you here. Now see here, model.eval, we evaluate the model and it is set to evaluate a model, right? Okay, with torch.noGrade, this is the format to evaluate in which we test the data. Okay, this is also fine. Predictions equal to model x tensor.numpy, we have passed the data in the numpy format. Here we are passing the data x test tensor, but we in the numpy format. After that, prediction rescaled and scalar.inverse transform, and then after the prediction again it will be reverse transform. Inverse transform convert the value to its actual form like reverse. Okay, inverse transform converts the value to its actual form. For example, in the initially we have seen that the data is converted into different type of data, right, that the machine learning understand, but again after doing all the operations it will be converted to its original form. Okay, so now what we are doing here, just do the another step. Now here evaluation is done, now we have to do the plotting. So now let's do this plot. Okay, now if you see here actual and the predicted, okay, so actual and predicted you can see almost very equal, close to each other, right? In few places there is no overlapping, otherwise normally, so it will be a good sign that it is saying that it is accurate. After that, now predicting new vendor. Okay, predicting new vendor, how the new vendor is doing. Okay, so now let's see this, predict new vendor quality. Now see, we have created one function, and that function we will pass quality, cost, delivery, compliance and responsiveness. These four independent variables we will pass. Okay, and this is with no grade, this is just a function return, right? Right now I have not passed the value, right? Now I am passing the value. So this is our values. Now see here, predict new vendor is the function name, here it is written. After that 1 2 3 4 5, 1 2 3 4 5. Okay, now see 9 7 8. Now see, quality means 9, cost 7, delivery 8, compliance is 9 and responsiveness 8.5. Now what if I put the enter button? Now see, suppose if I enter quality is very high, 99. 9 means instead of giving 9 I will take it as 19. Look at this. And suppose responsiveness, like if I change this, right, then look at this, it becomes high. Costing is very less, let's take 5. Let's take, look at this. Then you will see the delivery time. Right, so in this way what we have done, we have given 5 parameters: the person who sells the item good quality, the person who sells the item on a good vehicle without any damage, the person that gives you quick response, the person that sends you the quality one goods, right? So all these things, and on the reasonable rate also. So all these things are used for scoring the vendor scorecard. Clear? Now okay, now let's have a quick recap again. In this session, what we need to do, we have taken the data from NetSuite that is completely related to vendor. We have generated the report, and now we are just preparing a scorecard of a vendor, and these are the parameters, right? These are the things on which we select our vendor. Now here you will see, first of all, the libraries are downloaded, right? Secondly, we have to read the data, and we have to keep the data into data frame, that is data. Now following are the target. Yes, following are the target means the independent variables will be kept in one place and the dependent variables will be kept in another place. Okay, that is x and y variable. You will see x shape 1, that is 100 rows and 5 columns. Okay, similarly you will see here after this test split, we have to convert into standard scalar. Standard scalar fit to transform, because it has to fit the data, right? If the data is not fit properly, then it will not be able to calculate. That is why we have separated data: x train, x test, y train, y test. Okay. After that, you will see here vendor score model. Now vendor score model is here. The reason is that first of all we will just input the sheets. Okay, input the sheets. After that, vendor score model, we have to create the data. So here what will happen, input size is given. After that, 64 neural networks, that means 64 layers, will evaluate the data. ReLU function is executed. If there is any negative sign, then it will convert it into positive. Then linear 6432, again 64 is the output of previous but the input for current. Then 32 neural networks will be created. Okay, now here you will see model equal to vendor score model. Now vendor score model is created and criteria is MSE loss. MSE loss means difference between the actual score and predicted score. Okay, now if you see here, model equal to vendor score model, we have created MSE loss and then Optim Adams. After that we will see here the training part. Now this training part, epochs 200 times we have executed, right? And here each and every meaning return each time set of training mode. Then we will see optimize start with phrase 0, then pass the value of x, then let the epochs run. Now after running the epochs, you will see the loss is decreased. Now here you will see the model evaluation. Now the evaluation will be done. So evaluation, we evaluate the model and it is set to evaluate mode, right? And these are the steps that we need to follow. Now here you can see the plot actual prediction. We have to plot the actual versus prediction. So actual is blue and the predicted is orange. Now predicting new vendor. See, we have created a model and we are now going to predict a new vendor, that how this new vendor will behave like. See, based on our 5 years experience, we have downloaded the vendor's behavior in an Excel sheet. Now based on that Excel sheet, we are going to predict that how much score does he deserve. Okay, so that is why we use this. But sometimes what happens, if we give 100% accurate data, it will show the accurate only, right? So this is the most reliable way of generating the scorecard, right? Then here you will see example prediction. Example prediction, we have write down so many things, and finally it is shown that predicted test evaluation score is 13.72. So guys, this is all about the prediction of vendor scorecard. We have generated the vendor scorecard with the help of DNN. And my suggestion to you is to just go through this video again and again 2-3 times. You will understand each and everything related to this, right? And if still you have any doubt or error, you can note down into the, you can put down into the comment box, and then I will resolve it. Clear? So now just keep watching this video 2 to 3 times. Everything will be clear to you. Okay, so today we are going to conclude this session here, and this is most important session, right? And those who have joined my class today, then please share and subscribe my channel so that you will get all the videos links and the upcoming videos also, right? Okay guys, thanks a lot. Thanks for watching.